had no idea how it worked. I was just like, follow the diagram, join the components together. Oh, it makes it travel those now. Probably spent about 2 weeks working out why it didn't work when I first built it and trying to fix it. So that's part of the kind of cost of entry when you're building pedals. Often you build something and it won't work, and you'll spend like weeks thinking like, why isn't it working? That one, I think I've missed out 2 components in it. Just when I transferred it off the little prototype board into actual soldered pedal, I just missed. So that's what made me more methodical in transferring the stuff. Second one I built was this 4-stage phaser. It's actually just a MXR phase 90 with some extra controls. So this is when I started to get a bit of confidence. Like, what happens if I change this? I'll swap this out, or do this. Then I've got a load of overdrives, the 808, the TS9 tube screamers. That's got one of the original chips in it. That's a delay pedal called the Echo Bass, which is like a DIY project. So a load of DIYers came together, designed this Echo Bass based around a particular delay chip. It was quite popular at the time. And you could buy the PCB, so I just bought a PCB and populated it myself. Then I did a whole project on compressors. So I've got loads of compressors. There's one there, there's one there. The Ross, which is exactly the same circuit as the early Ross compressor, which is exactly the same circuit as the MXR compressor, same circuit. There's an operational transconductance amplifier to make a signal, which is quite interesting. Wrote an MA thesis on compression actually, and these were part of it. And then I started messing around with other people's circuits, and this is a 5-control fuzz pedal, which some guitarists may recognise.
Yeah, the Z-Vax.
Yeah. You're not allowed to say it's a fuzz factory, because it's actually annoyed.
Is it 5-knot?
5-knot fuzz.
Is it germanium?
That one is, yeah. Cool. So, they were the catalyst, I suppose you call it, which led me to have a problem, although we don't call it that, we call it a passion instead. So, if anybody wants to talk about the esoteric qualities of Soviet bloc germanium point diodes, then I'm happy to talk about that for hours. These are said diodes. Brought some with me so we can try some out. Circuits.
New old stock.
New old stock, yeah. They're cheaper than the Mollard and the British Rollins ones.
Oh,
So usually you buy in bulk still. These cost like a couple of quid each, which is phenomenally expensive for an electronic component. So today we're going to build this. It's fairly simple. It's called, this isn't a typo, it's called the Baz Bus. It was designed by a local Christian, or Hemo, as he's also called. It's very easy to build, providing you've got a bit of dexterity to build it on that small board, but we'll go through it step by step. It's quite hard to understand what's going on because of the way that this component is biased by that diode. Means that it changes based on what your guitar signal is doing. So, in terms of understanding, I would say probably not the best one to try and understand first. But the reason that I've chosen it today is, one, it's easy to build, and two, you can change just about any component in it, it'll change the sound of it. So it's very easy to experiment with, as you'll see. You can do some cool things with it, like replace this diode with a green LED, and it actually flashes in time with your playing. I also put some green LEDs so you can try it. So let's have a look at what's in your kit. So open your kit. Try not to lose all the tiny little components. You do have spares. I've done this before. One of the things that I learned early on building pedals is, and print it, sounds nice print out from this website. I usually have like a hand-drawn quick sketch of the circuit I'm working on, thinking about it and drawing it. Okay. But what I'll do these days is lay out my components on the page, so I can see I've got them all priced out. I've done it here so you can see what you've got in front of you there. I'm zooming in a little bit. You should have, tell me if you're missing anything, and I'll find you. You should have 2 jacks. One for your input, one for your output. They've probably got different colour leads coming off them, black and yellow and black and blue, is it? Yeah. So the black should be soldered to the ring of the jack. If you look at it, that'll be your ground connection. I soldered these myself, so I'm saying that. I've checked them, but I might have made a mistake. It has been known to happen. Should have got battery snap. Now, I haven't given you a battery because they're bloody expensive, but I've got a bunch of batteries that you can use to test it with. You can actually buy for £1, I think, in the pound shop, or they're £2 now in the pound shop, probably 2. Nothing's a pound in the pound shop, is it anymore?
All moving to alkaline to get more expensive.
Yeah. So these are your power connection, guitar in, guitar out. So you've got your external world connections coming into your breadboard. Alright, everyone got that? Yeah. Then you've got a tiny little multi-layer ceramic capacitor that looks like this. And that, in this case, is 100 nanofarads. So capacitors are measured in farads, but a farad is a massive value. So when we look at guitar pedal capacitors, they're usually measured in nanofarads or microfarads. So micro is a million, and nano is 1,000 millionth or a billion. So what this is doing here is it's blocking any voltage getting back into our guitar. So it's just letting the guitar signal through. If we change the value of this, it would change what frequency you signal through here. Now we can try that later on. We can swap that one and that one around and see what happens. Then we have 2 components here that are called semiconductors. One is a diode. This is the heart of your circuit, and it's tiny. It looks like this, and you should see there's a tiny little black stripe on one end of it. You've all got one more than 914. And I can tell you, you'll also see 1N4148 there sometimes. There's no difference in guitar circuits between the two. Get into radio circuits, there's a slight difference. But in guitar circuits, you can swap them the same. Then we have a transistor, which is our other semiconductor. And this, in this circuit, is acting like an amplifier, basically. It's amplifying your signal. So these two things working together to amplify and then change your signal in some way. In this case, it's clicking it, but it's doing it differently based on whether your guitar signal is plus a voltage or minus voltage. And we can change these with different transistor, different diode, it will still work. That's why I chose this circuit. So in order to get this transistor to work, it's a bit like a tap. Think about a tap. You need to turn the tap on for it to work. So with the transistor, for it to turn on, you need to send some kind of voltage into here, which is called the base. So here we're getting some of our positive voltage through a resistor. So this is resisting the flow of current. Going down here, it's going through the diode and into the base. And it's holding this transistor open, so it's on basically. Without this, or some other form of biasing, you've probably heard that term before, right? On guitar player, biasing. Talk about biasing valve amps. This is kind of an integrated version of a valve. So we're doing the same thing here, we're biasing it to work. Turning this on, it amplifies the signal, and it comes out of here. It comes out here, it's controlling power down here, and it's being fluctuated by this component. So what you're getting here is a signal that's like your guitar signal, only louder, and then at some point it gets so loud that it can't handle it and it clips it, and that's where you get your fuzz from. Now here we've got voltage, and we're losing some voltage across here, and we're losing some voltage across here, and we're losing 0.7 volts, or 0.6 to 0.7 volts through here. But that means here, which is where our output's taken from, we're still going to have some voltage from the battery. Do we want battery voltage on our guitar signal? No. So we use another capacitor to block it. So if you use a capacitor, it will only let your guitar signal through. Unless you work for SSL, and then you don't use capacitors. Did you know that? SSL don't use capacitors in the audio circuit. So when it comes out of here, because we've amplified it, it may be a bit loud. Now when you're designing a circuit, you can just take that, plug it into your amp if you want, and just use your amp volume control, turn it up and down, and your guitar volume control to control the gain. It's like gain volume. But I've given you a tiny little thumb adjustable pot in there as well, so you can adjust the volume of it, which is useful if you don't want to blow up your amp. You take it home later and plug it into your amp. Just make sure it's turned down first and then bring it up gradually. Or doesn't usually blow up your amp. It can make you jump out of your skin if you're not prepared for loud sound. So this is called a potentiometer. So it looks like a resistor. One thing I'll just point out, if you look at my diagram I've drawn on the board there, you'll see that my resistor symbols are different. So they're European symbols, they're American symbols, I mean the same thing, just different ways of drawing them basically. That's a resistor there, so that. Either way is fine, they're pretty much interchangeable these days, but not in the same schematic. So just with each schematic, just stick to one. I often just draw that because it's easier to when you draw with a pencil. Is everyone still with me?
Yep.
Yeah.
Are you feeling confident? Okay.
Fairly.
So, the trickiest bit of this is it takes a little bit of dexterity. And I think the trickiest bit of building this circuit on such a small breadboard is getting this thing to fit with stuff coming into it and out of it. So what I'm going to do now is show you a series of pictures and we can do a build along. Hopefully we'll all end up with a working circuit. If we don't end up with a working circuit, which may happen in some cases, we can test my ability to spot what's wrong with it. It's usually just that something's not connected together or something's in backwards. Or So the very first thing, .92k, so there's effectively 100k. Why is it 99.92 and not exactly 100? Tolerances? Because it's within so many percent of 100k. So if you put your resistor in there, it will measure something slightly different to this one. So that's what the last band on the resistor tells you, it's tolerance. So in the case of these are carbon. They're not things that are the other time.
It's like the magnetite, which is the green one.
Carbon films.
Yeah,
These are carbon film. So they'll have a wider tolerance than a metal film. Metal film are way more and less noisy as well.
Yeah, there are people, like some people that like neon stuff, they prefer the carbon one.
Carbon composition, yeah.
Yeah. But it's something simple almost.
I actually did the Heath Robinson approach here. So we're taking this diode, and notice the black stripe here, from the collector back into the base. If you look here, you'll see it's going from the collector back into the base. This battery is 9.26 volts. That's fine.
Got some extra.
No. Oh, you did? What's the legend? I'm just thinking I don't have another lead. I do. So I'm not going to connect the battery yet. I'm going to attempt to. I'm going to turn down the amp. I'm going to connect my circuit.
Stu, it might have the distortion setting already on
I've
it.
changed it. Changed it. Thanks, Ben. This, I just called you a legend. You missed it. This is my jack going into the amp. So which socket is it coming out of?
Yeah,
Which is the amp? How do I know which one's the amp? Because it's got the
also the arrow with like three
Yeah.
points pointing through.
potentiometers, the word you're looking for.
Potentiometer.
Hot. You'll also hit. Yep, called. Or you could just call it volume control if you want as well. But yeah, lots of guitarists just call them pots.
Yeah.
Which is short for potentiometer. I'm just trying to balance this so the cable doesn't pull off the circuit. There's no guarantee this is going to work, by the way. It often doesn't work when you plug it in.
Drum roll.
And in fact, I'll probably be more disappointed if it does work, because then there won't be any fault finding to do. Okay, so I've plugged in everything now. I'm now going to power it up. Cue the smoke. And then this is where if I was feeling really evil, I would have shouted bang. one thing that you can check is whether the transistor's getting hot. I don't recommend doing what I just did and putting a finger on it, because I've done that before and I've burnt my finger. That's a good sign.
Yeah.
So it's like,
Woo!
it's slightly disappointed. So we've got no way of bypassing it at the moment. But you'll just have to. That is about half on, I think. So that is just the sound of that circuit that you just made before we start messing around with it and doing any experimentation. So each of you are going to bring us up and we'll plug it in and test it.
Sweet. Yeah, it's already filming. Yeah, I go the guys in shoegazer t-shirt on. Got to make this happen.
Right, next.
Yeah, I'll go up.
We insist on mixed version.
The guy with the shoegazer t-shirt on. Yeah, I got to see that.
You have also impulse.
Yeah, this t-shirt.
I don't think you have so this is
Oh.
Right.
Yeah.
Sam.
I've done it again, haven't I? I'm getting lazy now. First like 10 pedals and down, and now I'm getting lazy.
Force dynamics.
Okay. Ready?
What happens if you put both the discs in the coffee? Maybe it would be better.
So you're just DIing into your computer.
There it is. And the t-shirt.
Just remember who
Thank
wrote
you.
that.
Oh no, what is it?
That was a Sonic Tap reference, but it
To your studio.
Thank you.
So what happens to coffee? If you leave it long enough, it becomes a beer.
Pretty good product. We're going to go into pedal building now.
Oh wow, it makes me
Right.
That's enough.
Thank you.